Assalamu alaikum. My name is Rafiq Ahmad. I am Assistant Professor, Department of Physics, Government College, Nawabshah. Dear students, today my lecture belongs to the class BSc Part 2, Paper 4 and Inter, Chapter number 19. For both classes, inshallah, my lecture will be beneficial. The topic of my lecture is the half-life. Half-life can be defined as the time required for one half of the radioactive substance to disintegrate. Half-life denoted by T1/2 and its unit described in seconds, days as well as in years. Half-life is different for different elements depend upon the radioactive constant, that is lambda, as we derived in the law of radioactive decay. According to law of radioactive decay, we know N is equal to N naught E minus lambda T. Now, according to definition, half-life is the time in which the half of the elements will be disintegrated. I describe this definition by a little experiment. Suppose I have a glass of water. This water contains N naught molecules. Suppose the water is considered as the radioactive elements. N naught is a number of actual elements, and T1/2, this is the time required to disintegrate the half of elements from this glass. Okay, suppose now the water level has been reduced, reached at the N0/2. It means the half of the elements has been disintegrated from this glass. So the time required to disintegrate these atoms from the glass is T is equal to T1/2, and number of elements remaining are N is equal to N0/2. So put these values in this equation. So N is equal to N0/2 is equal to N0 E minus lambda T1/2. Okay. Now N0 will be cancelled. So we have 1/2 is equal to E minus lambda T1/2. Reciprocal this equation. So the 2 is equal to 1/E minus lambda T1/2, or 2 is equal to E lambda T1/2, lambda T1/2, or 2 is equal to E lambda T1/2. Apply log to both sides. Apply log to both sides. So the log 2 is equal to log E lambda T1/2. So log 2 is equal to 0.693 is equal to log and exponential function are inverse to each other. So we have lambda T1/2 or T1/2 is equal to 0.693 upon lambda. So this is the equation of the half-life time of the radioactive element. Now we do some numericals regarding to the half-life. Numerical number 1 is the disintegration constant of radioactive element. Numerical number 1, the disintegration constant is lambda of radioactive element is 0.00231 per day. Is 0.00231 per day. Calculate the half-life. Calculate half-life. So very easy numerical. First of all, we make a data. Now lambda is equal to 0.00231 per day, and we have to find T 1/2. So from this formula of the half-life, T 1/2 is equals 0.693 upon lambda. So T 1/2 is equal to 0.693 upon, insert the value of the lambda, 0.00231. So that when you get the solution will be about 300 days. Its answer will be about 300 days. Suppose this radioactive element is suppose the mass is 100 gram. So after 300 days, its mass will be 50 gram. Means after 300 days, this element whose mass is 100 gram, after 300 days, its mass will be 50 gram. After 300 days, its mass will be equals to 25 gram. After 300 days, its mass will be 12.5 gram. So after 300 days, its mass will be half and half, and this system is going on. Now second numerical. Hope you understand this numerical. Now we do a second numerical. Find the radioactive constant of radium. Second numerical. Find the radioactive constant of radium whose half-life is 1620 years. Now we apply same formula. First off, we'll make a data. इसके डेटा बनाएंगे. So half time हमें given है 1620 years. T 1/2 is equal to 1620 years. And we have to find the lambda. So formula is T 1/2 is equal to 0.693 divided by lambda. So lambda is equal to 0.693 divided by T 1/2. So the lambda is equal to 0.693 divided by 1620. So the lambda will be is equal to, इसको हम solve करेंगे. So lambda will be about 4.28 into 10 power minus 4 per year. So this is the answer. Okay. Hope you understand this numerical. Numerical number 3 is certain radioactive substance has disintegration constant. Lambda is equal to 1.44 10 power minus 3 per hour. In what time 75% atoms disintegrate? This is a very amazing problem. Now first of all we make a data. 1.44 10 power minus 3 per hour. We have to find the time in which the 75% of the radioactive elements has been disintegrated. So these are the original numbers minus the 75% of the radioactive nuclei are disintegrated. Once again, N0 is the number of radioactive elements present. Minus 75% means 75% radioactive nuclei are disintegrated from these number of the nuclei, original number of nuclei. 75% disintegration हो रही है N0 से, तो ये माइनस हो जाएगा. So N0 is common. We have 1 minus 75%. Now N0 is equal to 1 minus 75 upon 100, or N0 1 minus 3 upon 4. 1 minus 3 upon 4 will be equals to 1 upon 4. So the N is equal to N0 into 1 minus 3 upon 4. If you take the LCM, so it will be equals to 3 1 upon 4. So the N will be equals to N0 upon 4. Or N upon N0 is equal to 1 upon 4. According to law of radioactive decay, N is equal to N0 E minus lambda T, or N upon N0 is equal to E minus lambda T. N upon N0 is equal to 1 upon 4 is equal to E minus lambda T, or 4 is equal to 1 upon E minus lambda T, or 4 is equal to E lambda T. We apply the log to both sides. So the log N is equal to log E lambda T. So log, sorry, not N, log 4. So log 4 is equal to log and exponential function will be cancelled. So we have a lambda T, or T is equal to log 4 upon lambda. T is equal to, the value of log 4 is 1.386. Log 4 value is 1.386 divided by lambda. Lambda is given 1.44 10 power minus 3. 1.44 into 10 power minus 3. So when we divide the denominator and numerators, we will get a value 962.7. 962.7 years. So remember, after 962.7 years, the 75% disintegration will be happen in the radioactive nuclide. This is the answer. For numerical, a carbon specimen found in a cave contained 1/8 as much carbon 14 as an equal amount of carbon in living matter. Calculate approximate age of that specimen, and half-life of carbon 14 is 5,568 years. This value is very important for the MCQ and B for MCQ. The half-life of carbon is 5,568 years. We have to find the time of that specimen. Suppose this is a specimen which contains carbon 14. We found from the cave. Now we have to calculate how much time is older. So first of all, we find the lambda. According to half-life time period, T 1/2 is equal to 0.693 upon lambda. Lambda is equal to 0.693 upon T 1/2. So the lambda is equal to 0.693 upon 5,568. From the law of radioactive decay, N is equal to N naught E minus lambda T. 1/8. The specimen contains 1/8 of much carbon 14. So the N is equal to 1/8 into N naught, or N upon N naught is equal to 1/8. So the N upon N naught is equal to E minus lambda T. N upon N naught is equal to 1/8. So the 1/8 is equal to E minus lambda T. Reciprocal both sides. So the 8 is equal to 1/E minus lambda T, or 8 is equal to E lambda T. Apply log. So log 8 is equal to log E lambda T. So we know the log and exponent function are reversed to each other. So the log 8 is equal to lambda T. So the T is equal to log 8 divided by lambda. So the T is equal to, the value of lambda 8 is equal to 2.079 divided by lambda 0.693 upon 5568. So when you get the solution, the final answer will be about 16707. 16707 years. This is the life of dead specimen. This is answer. Hope you understand my lecture. Thank you very much.